This video will be the second portion of examples about separation of variables. Solve the logistic equation. So we want to figure out what P is in explicit terms with T. Okay, we always start by replacing P prime with dP dt. And then use separation of variables, so we get dP over P times 1 minus P over K equals R. And then we want to integrate. But in order to integrate this side, we're going to have to use partial fractions expansion, meaning we want to write 1 over P times 1 minus P over K in the form of A over P plus B over 1 minus P over K. And so we can write that A times 1 minus P over K plus B times P equals 1 for all P. Now I'm going to go ahead and plug in P equals 0, and that tells me that A times 1 plus B times 0 equals 1, so A equals 1. And then if I plug in P equals K, then I get that A times 1 minus K over K, or just A times 0, plus B times K equals 1, which tells us that B equals 1 over K. And now we can rewrite our integral of dP over P times 1 minus P over K as the integral of 1 over P plus 1 over K over 1 minus P over K dP. And here we can bring back in the right-hand side. We had that equal to the integral of R dt. Now we can take the integral of this side pretty easily. That'll be the ln of P minus the ln of 1 minus P over K. And that equals R times T plus C. And then, using a property of logarithms, we can write this. Then e to the power of RT plus C. In this case, I'm just going to move the C down here. And that equals P over 1 minus P over K. Here we can plug in our initial condition, which was that P at time t equals 0. We'll just call that P0. So we'll use that in order to find C. Plugging in t equals 0 gives us C on one side and PO over 1 minus PO over K, or simplified, PO times K over K minus PO. Now, taking this first equation that we have here, we can do a bit of algebra and rearranging to get that P is equal to C e to the RT over 1 plus 1 over K times C e to the RT. And then we can go ahead and plug in what we know about C. So that tells us that P equals KPO over K minus PO times e to the RT over 1 plus PO over K minus PO times e to the RT. We'll multiply both the bottom and the top by K minus PO, and that'll give us KPO e to the RT over K minus PO plus PO times e to the RT. Or if you wanted to rearrange that, you could also have it as kpo over po plus k minus po times e to the minus rt, which is another common way you'll see this equation written.